Alright, let's review about what we know about the exponential function and its inverse. So if f of x equals b to the x is our exponential function, then its inverse, f inverse of x, is equal to the log base b of x. Alright, so what does this mean graphically? Well, let's first look at the case where b is larger than 1. So for example, 2, 3, e. So f of x equals 2 to the x, f of x equals 3 to the x, or f of x equals e to the x are examples. Its graph will take on this general form. So it'll pass through the point 0, 1. As x gets large, f of x gets large, and as x gets large, negative, f of x goes towards 0. It has the line y equals 0 as its horizontal asymptote. So its inverse will be a reflection about the line y equals x. This means it'll pass through the point 1, 0, and the horizontal asymptote of our exponential function will give a vertical asymptote, x equals 0, for our log function. Let's see how this changes when we are talking about a base that is less than 1. Okay, so if my base is somewhere between 0 and 1, for example, 1/2, 1/3, 1/10, then it'll take on this general shape. It still passes through the point 0, 1. It still has a horizontal asymptote y equals 0, but this time as x gets large, f of x goes towards 0, and as x gets large, negative, f of x goes towards positive infinity. Its inverse is also a reflection about the line y equals x, which means its inverse, or the log base b of x, will pass through the point 1, 0. The horizontal asymptote of the exponential function gives a vertical asymptote, x equals 0, for the log function. All right, what other properties do the inverses have? Well, we know that if you compose a function and its inverse, then you get back what you started with. So f composed with f inverse of x equals x, and f inverse composed with f of x also gives x. So what does this mean? Well, this means if I compose f with its inverse, I get b to the log base b of x, which I know gives x. Likewise, if I compose f inverse with f, I'll get log base b of b to the x, and I know this gives x. So another way to think of this, what happens if I have b raised to the log base b of something, blob, then blob comes out. B to the log base b of blob equals blob. And the log base b of b to the blob also equals blob. Now let's look at some examples. Start right here. If I have the log base 3 of 3 squared, the 2 comes out. The 2 is my blob. So log base 3 of 3 squared is 2. The log base 5 of 5 to the 1/2 is 1/2. The log base e of e to the 8th is 8. Let's look at something that's a little trickier. If I have ln of e, which we know to be the natural log of e, is equal to 1 by the same principles. And let's see why. Well, the natural log of e is really the log base e of e, and if I have log base e of e, that really means I'm raising e to that first power, so I really have the log base e of e to the 1, which we know equals 1. What about this one? The log base 5 of the square root of 5. Well, I need to have bases that are the same. I need to have a 5 here and a 5 here. But if I remember my exponent rules, I know that the log base 5 of the square root of 5 is the same thing as the log base 5 of 5 to the 1/2. And the log base 5 of 5 to the blob equals blob. Let's look at one more. The log base 8 of 8 times 8 to the 1/2. Well, this isn't quite what I need. I need to have log base 8 of 8 to the blob, and I don't have that. But, again, I apply my exponent rules. This is really equal to the log base 8 of 8 to the 1 plus 1/2.